All right, today we're talking about complex numbers, which means we get to learn how to take the square root of a negative. The key thing to remember when taking the square root of a negative number is the square root of -1 is I. I stands for imaginary, so we are now introducing complex or imaginary numbers into our math skill set. All right, the square root of -16. Well, we know that the square root of 16 would be 4, so we can treat this the way that we would treat square root of 16 times -1. It's just that now we know -1 is a perfect square. The square root of 16 is 4. The square root of -1 is I. So the square root of -16 is 4i. The square root of -81 would be 9i, right? The I takes care of the negative part, and 9 is the square root of 81. Square root of -45, all right? That would be like 9 times 5 times -1, right? Square root of 9 is 3, square root of -1 is I, and the square root of 5 can't be simplified. 3i all in the square root of 5. The I, taking the square root of -1, takes care of the negative part of the radicand. All right, the square root of 200, -200. Think about this as 100 times 2 times -1. Square root of 100 is 10. Square root of 2 will be left over. Square root of -1 is I. So this is 10i on the square root of 2. All right, number 5, square root of -48. 16 times 3 gets us 48, and 16 is the largest perfect square that goes into 48. And then with the negative part, we'll use -1. So this is 4i on the square root of 3. Square root of -144 is going to be 12i. Square root of -108. 36 is the largest perfect square that goes into 108. 36 is 6. 3 can't be simplified. Square root of -1 is I. So this is 6i on the square root of 3. Square root of -75. 75 is 25 times 3, and then times -1 for the negative part. So this is 5i on the square root of 3. If there is a negative under the radical, then we take care of it by taking the square root of -1, which is I. All right. Another rule about I is that in order for it to be fully simplified, the only power of I can be 1. So the only exponent allowed is a 1. So we have to learn how to simplify any exponent that is greater than 1. I to the first power is just I, right? I squared is -1. Because I is the square root of -1, when we do I times I, right, the square root of -1 times the square root of -1 is -1. All right, I to the third. So if you think about that as I times I times I, right, we know I times I is -1 times I again. I to the third is -I, right? I to the fourth power. I times I times I times I. Okay, so I times I is -1. I times I, -1. -1 times -1 gets us +1. I to the fourth power. So any power of I past 4, it's just going to be a cycle after this. Because I to the fifth, think about if I take this and I multiply it by I again, that gets me back to I. And the cycle just starts over. So it is a cycle of 4. So when the exponent is greater than 4, we just divide the exponent by 4 to find out where we are in the cycle. If it goes in evenly, that means we're at I to the fourth, so it'll simplify to be +1. If it doesn't go in evenly, look at what the remainder is when you divide it by 4. The exponent is what we're dividing. If the remainder is 1, we're at I to the first power. If the remainder is 2, we're at -1. And if the remainder is 3, we are at -I. All right, so 13 is the exponent. Divide that by 4. 3 times 4 is 12, and it has a remainder of 1. So that means number I to the 13th power simplifies to just be I to the first. Number 10, let's look at our exponent here is 27, right? Divide 27 by 4. 6 times 4 is 24, and that leaves us with the remainder of 3. So that means I to the 27th is equivalent to I to the 3rd, which we said simplified to be negative I. All right, I to the 54th power. Divide 54 by 4. 4 goes into 5 one time. And 4 goes into 14 3 times. 3 times 4 is 12, leaving us with the remainder of 2. So this is like I squared, which we know is negative 1. Remember, it's the remainder that tells us what our exponent is. I to the 72nd power. 72 is divisible by 4. It goes in 18 times. All right, so since it goes in evenly or has a remainder of 0, that tells us this is positive 1, I to the 4th power. All right, on your notes sheet, the multiplication symbol's printed correctly, but on my notes page, they turned into G's. So everywhere you see a G on here, it should actually be a multiplication sign. All right, down here, we're combining our exponent rules, and then we're going to simplify what's left. So I to the 9th times I to the 6th is I to the 15th power, right? When you multiply like bases, you add their exponents. So then we just need to divide 15 by 4. And 4 goes into 15 3 times with a remainder of 3. So this is really I to the 3rd power, which is negative I. I to the 12th divided by I to the 8th. When you have like bases being divided, you subtract their exponents, which tells you we're looking at I to the 4th. So this is positive 1. All right, I to the 62nd times I to the 17th over I to the 23rd. I will multiply in the numerator first. That's going to give me I to the 79th power divided by I to the 23rd. Again, when you divide like bases, you subtract their exponent, and this leaves us with I to the 56th power. Divide 56 by 4. All right, 4 goes in evenly. So that tells us we're looking at I to the 4th power, which is positive 1. Number 16, I to the 8th times I to the 23rd. This will give us I to the 31st power because we have to add the exponents since we are multiplying like bases. 4 does not go in evenly to 31, right? It's going to have a remainder. 7 times 4 is 28, leaving us with a remainder of 3. So that means this is really I to the 3rd, which is negative I. Next up, complex numbers in the complex plane. So the complex plane has a real axis where normally we see the x-axis and the imaginary axis where we would normally have the y-axis. Standard form of a complex number is a plus bi, where a is the real part and bi is the imaginary part. So to describe the value of a, you look at the x-axis to find the real part, negative 2, and you look at the imaginary axis to find the imaginary part, 5i. So a is negative 2 plus 5i. B, the real part is positive 2, and the imaginary part is 2i. So b should be 2 plus 2i. For C, the real part is at positive 4, and the imaginary part is at negative 3. So this is 4 minus 3i. For D, the real part is at negative 4, and the imaginary part is at negative 3. So D should be negative 4 minus 3i. All right, next up is the absolute value of complex numbers. Absolute value is the distance from 0, all right? So we can use the square root of a squared plus b squared to find the absolute value of our complex numbers. A is the real part, and B is the coefficient of the imaginary part. A from before was the point -2 plus 5i, right? So to find the absolute value of A, we need to do the square root of -2 squared plus 5 squared, right? We just take the coefficient of the imaginary part. So this is 4 plus 25. The absolute value of A is the square root of 25. All right, let's take a look at C. C from earlier was 4 minus 3i. So A squared, we're going to take the real part, 4, and square it, plus, take the coefficient of the imaginary part, -3, square it. This gets us 16 plus 9. So the absolute value of 4 minus 3i is the square root of 25, which simplifies to be 5. Okay, let's look at adding and subtracting complex numbers. Right, to add and subtract complex numbers, it's very similar to adding and subtracting variable expressions. We're going to combine the real parts, so the real parts are like terms with each other, and we're going to combine the imaginary parts, right? Any powers that are greater than 1 need to be simplified before we say our final answer. For number 19, we're just combining like terms. Everything's addition. There's nothing to simplify inside the parentheses. So the real parts are like terms. 7 and 3 make 10. 2i and 6i, the imaginary parts are like terms. So this is 8i. On number 20, we do need to make sure we distribute the negative. So this is 6 minus 5i minus 1 minus 2i. 6 minus 1 is 5, -5i minus 2i, -7i. Right. On these two, I only has an exponent of 1, so we didn't have any further simplifying to do. On number 21, we're going to treat the i's like we would treat any other variable. I to the 4th will be a like term with the other I to the 4th, and I to the 3rd will be a like term with the other I to the 3rd. Make sure you distribute your negative. So this is 11i to the 4th plus 4i to the 3rd minus 2i to the 4th plus 6i to the 3rd. This gets me 9i to the 4th plus 10i to the 3rd. Now, we do need to simplify those powers of I since they are greater than 1. All right, 9i to the 4th. We know that I to the 4th is positive 1. So this is 9 times positive 1, which we know will just be 9. Plus, I to the 3rd is negative I, so this becomes negative 10i. So our final answer here is 9 minus 10i. All right, 22. Distribute the negative. 9 minus 10 minus 2i minus 5i. Combining our like terms, we're going to get -1 minus 7i. 23, we need to distribute the 6i. So I've got 5i squared plus 24i minus 18i squared. 5i squared and -18i squared are like terms, so that leaves us with -13i squared plus 24i. I squared is -1, so this is like 13 times -1 plus 24i. So fully simplified, this is 13 plus 24i. Number 24. 3i minus 4 minus 4i squared plus 3i. Distribute the negative. 3i minus 4 minus 4i squared minus 3i. All right, this will get us, let's see, 3i and then minus 3i. 3i minus 3i is 0. So we really just have -4 minus 4i squared. Well, minus 4i squared. I squared is -1, so this is -4 minus -4. Therefore, this becomes negative 4 plus 4, so it simplifies to 0. Multiplying complex numbers. We're going to treat the i's like we would treat any other variable, and then we would simplify any powers that are greater than 1. So for number 25, this is negative 3i minus I squared. Right? I squared becomes negative 1. So this is negative 3i minus negative 1. Double negative turns positive. So this is 1 minus 3i. 26. Do double distribution. Negative 12 minus 4i minus 18i minus 6i squared. Negative 12 minus 22i minus 6i squared becomes minus 6 times negative 1. So that becomes positive 6. So I've got negative 12 minus 22i plus 6. So our final answer is negative 6 minus 22i. All right, let's FOIL on 27. Negative 24 plus 15i plus 8i plus 5i squared. All right, so this is negative 24 plus 23i, and then plus 5i squared turns into minus 5, because this is 5 times negative 1. So we get negative 29 plus 23i. All right, 4 plus 3i times 4 minus 3i. Doing FOIL again, this gets us 16 minus 12i plus 12i minus 9i squared. The positive and negative 12i cancel each other out, and minus 9i squared becomes plus 9. So this is 25. These are what we call complex conjugates of each other. Whenever you multiply complex conjugates together, the product will always be a real number. For 29, we just need to distribute. This will be negative 2i minus 8i squared. When we simplify this, it's negative 2i plus 8, so we want to write 8 minus 2i. All right, one more FOIL. Negative 15 minus 27i plus 10i plus 18i squared. This gets us negative 15 minus 17i minus 18. So it's negative 33 minus 17i. All right, that's part 1 of the video. We're going to finish talking about complex conjugates and dividing complex numbers tomorrow. So there will be part 2 for this video.